This is like an ongoing video to try and keep this Rohde Schwarz from being scrapped, really. It's using a couple of my other videos, I've redone the caps, replaced all the caps. So I've just replaced the capacitors in the power amplifier. This is the power amplifier section here. The problem with the power amplifier is someone's been in there and they ran right balls up with the rewiring. I can't get a manual. I'm negotiating a manual from someone in Germany at the moment, but the generator, the amplifier needs a 50 volt B plus, if you like, to run the RF amplifier. And what someone had done, I don't know exactly know why he did it and how he did it, was he'd taken there's an unregulated 80 volt feed from the amplifier that's now was fed into the signal generator, into the RF amplifier via this connection here. This is a connection I've made. It was originally in this ribbon cable. So they'd taken the 80 volts and tried to regulate it down to 20 volts with a linear regulator. Well, needless to say, the linear regulator blew up, and it was putting neat 80 volts in, which is basically fried the amplifier. So that didn't work. So what I've done is I've replaced all the capacitors that were in this amplifier. This amplifier does get quite hot in operation. And what I've done is I mounted an external regulator. I don't know if you can see it here. It's not easy to see. I mounted it underneath. You can see this transistor here. There's a transistor here and a couple of Zeners to regulate the line down to 50 volts. So I've now got a reasonably well regulated supply to this point here, 50 volts. I bypassed the linear regulator that was fitted, taken that out and bypassed it totally. So I've got a reasonably well regulated supply to the power amplifier, and that's good. The generator works mostly, and what I mean by that is the set has been deteriorating. Also the other damage that was done to the amplifier is it looks like it's had a reverse power spike up it. There's a chip here, you can see where there's a 14-pin dual inline chip here that's been removed and is no longer in fitted, and all these chips here are op amps, 741 operational amplifiers, and M741s. So I think what that is part of the reverse power protection. Now that's all been disabled, so this amplifier is sort of exposed to you know, any fault that comes in from the input, so you have to be pretty careful of what I'm doing. So basically the amplifier works. Let me show you. There's the signal on the scope. Well, that's fine. Now you can see the scope's working fine. Tune the tuning scale, and you can see that's absolutely fine. And it will work on all the channels, no problem at all, apart from the bottom range. The bottom range is very intermittent and very weak, and doesn't always work. You see the waveform drops totally off when I start tuning, and that's actually working fairly well at the moment. Now what I've done is I've worked the signal back, so from the power amplifier the signal is injected, the signal comes in here, and the next point of call is the attenuator, and then it feeds into these two ports here, which are to the front attenuator at the front, and the next port of call is this main power amplifier, or the pre-stage of the power amplifier. You've got a large heatsink here that runs this surface mount RF transistor. Now this board gets very, very hot, and I've always thought there's been a problem with that, but you can see I've recapped it all, but there's still a problem, and I'm not sure why, but I think I've possibly found the problem. If you look here, there are two reed relays. What it looks like they do is they're like a bandpass filter for the amplifier. So from one range, say the first range, one relay does that, the first relay engages, and from all the higher ranges the second relay engages. You can actually hear them clicking in and out. The first range, the lower range that's faulty, is actually generated by this board here that I've marked up myself. I found that if you pull that out, you lose the output altogether on the low range, but all the upper ranges work fine. So I've been going through it all and trying to work out what's happening, and I think I've possibly come to the reason why there's a problem. So what I'll do is I'll take the board off and show you. Okay, so this is the first read relay, and this does the higher ranges. Now the black crocodile clip's connected to the fluke meter here on continuity test, and if you look now, this is a single pole double throw read switch or read relay. That connection at the back there is one of the coils, and the other coil is on the back, the other side. You can't see it's under the heatsink. So if I connect to the first connection there, there's no continuity. That's fair enough. Go to the second relay, there's continuity, and when you engage power into the relay, it flips it to this contact here. So it's like a changeover switch. That's fine, that's working fine. Now this is for the low range on the signal generator. If I connect the connection to there, I go to the first connection here, no connection, and then the second relay connection, still no connection. Now I have tried all sorts of things. I've tried running a demagnetizer on the reed, and you can hear it buzzing and things, but it won't bring the contact back. So it looks to me like this could be the problem. If this is a sort of stop band filter or a bandpass filter, and that is actually engaging on the low channel, which it certainly seems to do, that would be the cause of the problem. That would be the reason why the output would be so low on that range. So I think to prove that, what I'm going to do is try and bypass it and see if we get an improved output on the lower range. So let's try that. Okay, let's put the signal generator back on, make sure everything's ready to go. We're on the low range, and what I've done, it's very noisy now, and that's sort of what I'd expect. What I have done is I've connected the two connections of these Pomona leads to these two flying leads here, down here. So what I'm going to do is I'm going to short out that relay. So in theory, if this fixes it, it will give me a good signal on the lower range, and we should get off the scale on the scope, I would hope. I'm going to do it gently first of all through this decade box, just to prevent too much current flowing. I mean, it should be very small RF current anyway, but we're going through 100k, so let's connect that up. And straight away the waveform's changed. That's disconnected. That's connected. Okay, so we auto scale the scope. Okay, we've got a cleaner waveform. Bear in mind that when I touch the decade box, so what I'm going to do is I'm going to drop it to 1k. Okay, off the scale. So that looks to me like there's found the problem. Okay, that's 1k, 2k, so that's all obviously a fairly low source impedance, because that's a 1k resistor in series, and it's still acting like an attenuator. So let's try 700 ohms. It's starting to distort now. That's possibly because that distortion is possibly caused by the decade box having wire wound resistors in it, and they're acting as an inductor. So it looks like, hopefully, you won't see any more videos about this signal generator, because I hope that replacing that read relay will solve all the problems. Actually, what I might do at the moment, I might just see if it will still work on the higher ranges without any awful distortion, which it does seem to do. So what I might do Yeah, it seems to work fine on the other ranges, so all the time that works, that's fine. But yeah, thanks for watching, and I hope you found that interesting.